Hello everyone, thanks for joining in. Today we'll be going over and exploring the fundamentals of computer organization and architecture and focusing on I/O devices and bus systems and explaining what it does and the importance of it. If you're ready, let's begin and get to it. Alright, so our first topic is input-output in computer systems, also I/O. So input and output operations allow computers to interact with users and external devices. So the input devices provide a way for the users to send information and commands into the computer system, while the output devices present processed information back to the user. Without input and output mechanisms, a computer would not be able to receive instructions or communicate results. So these devices form an essential bridge between human interaction and then like the digital processing between our devices. So when a user types on a keyboard, clicks a mouse, or speaks into a microphone, the computer receives the data through these input devices. After processing the information, the system uses output devices such as the monitors or speakers to display the results. Okay, and now going more into input devices. The input devices will allow the user to provide the information to the computer system. These devices convert physical actions such as pressing keys or moving a mouse into digital signals that the computer can understand and process. So this process enables the system to interpret the user commands and respond accordingly. Common examples of input devices include the keyboards, the mice scanners, microphones, web cameras. Each device captures a different type of input. Um, for instance, a keyboard allows text entry while a microphone captures audio signals that can be processed by the computer. Okay, our next topic is output devices. So we just went over earlier in the previous slides the general layouts of both of these, and then we went from there to the input, and now we're going to the output. So the output devices, as we said, are responsible for presenting the results of a computer processing to the user. So after the CPU processes data, the information can then be converted into a format that humans can understand. Output devices perform this conversion by displaying images, reducing sound, or generating printed material. So common output devices include things like monitors, your printers, your speakers, projectors. For example, when a user runs a program or opens a document, the monitor displays the results of the computer's processing, so that the user can view and interact with the information that's being presented for them. Okay, so now we have device controllers. So device controllers are specialized hardware components that manage communication between the input and output devices and that between the computer system. So because each device operates differently, the controller acts as an intermediary that translates signals from the device into a format that the CPU and operating system can understand. So device controllers can also handle tasks such as buffering data, managing data transfers, and then controlling as well the timing of the communication between devices and the memory. So by performing these tasks, the controllers reduce the workload on the CPU, and it allows the input-output operations to function more efficiently. All right, so now we have the system bus. So the system bus is a communication system that connects major components of a computer, including the CPU, the memory, the input-output devices. It allows these components to send and receive information so that the system can operate as a unified structure. So whenever data moves between the processor, the memory, or the external devices, the system bus provides the pathway that carries this information. And without the system bus, then the different components of the computer would not be able to exchange the data efficiently. All right, so now we're going to be going over the types of system buses. So the system bus is divided into several specialized buses that perform different roles during data communication. So the data bus is responsible for transferring actual data between the CPU, the memory, and the input-output devices. It carries the information that the processor needs to read or write during the program execution. The address bus is used by the CPU to specify the location of the data in its memory. Meanwhile, the control bus carries the control signals that coordinate the system operations, such as the read and write commands. Together, these buses ensure that the data moves correctly between the components of the computer system. All right, so now we have synchronous versus asynchronous bus systems. So system buses can operate using either synchronous or asynchronous communication methods. So a synchronous bus uses a shared clock signal to coordinate data transfers between system components. Because every operation follows the same clock timing, synchronous buses can transfer data quickly and efficiently, making them common in many computer systems. An asynchronous bus does not rely on a shared clock signal. Instead, it uses handshaking signals to coordinate communication between the components. So this method provides greater flexibility when devices operate at different speeds, although it may introduce a slightly slower data transfer compared to synchronous systems though. Okay, and with that we have reached the end of this video. I hope this was helpful in teaching you more about input and output devices and then also system buses and the details about it and how it serves to function in hardware. Please feel free to like, comment, share, and subscribe, and stay tuned for the next video. Thanks.